Good afternoon. My name is Dominik Gößweiner. I'm working for the Austrian office of the German company Christian Pfeiffer, and therefore I'm mainly responsible for the wet grinding and mining division. Topic of my speech today is efficiency increase of mining mills by removing the ball scats. I know this is now not the right place to bore you with our company history, but at least I have prepared one page to give you some background. Christian Pfeiffer has been founded in 1925. Originally, we did a lot of dry grinding, especially for cement. And later in the 90s, we made also some wet grinding systems, mainly for power plants, for flue gas cleaning. But finally, we also arrived in mining operations. Anyhow, back to the topic, scats. What is scats? I have here also a picture. I took it in a silica mill, a wet mill, some years ago. We say the scats is this non-spherical ball fragments resulting from uneven wear inside the mill. Or it can be also some broken ball fragments, but this is mainly if you use casted grinding media. I have also one of these from a mill. It's diameter approximately 30 millimeters. And the question now, why removing these scats? If you do a research, you find a lot of papers, simulations, studies about the charge motion inside the mill, about the media shape influence of packing. Of course, we did also some simulations. The result was smaller balls with diameter 30 millimeters tend to go to the center of the charge. Bigger balls, in this case 50 millimeters, tend to go to the outside of the charge. But this is all theory. With a different lining system or a different mill speed, it can be completely the opposite. But the fact is that you have wear inside your mill, that the balls are getting smaller. And I have here an example. This is a typical ball charge. Let's say for a primary ball mill, you have 60 to 100 millimeter balls. You have here the quantity of balls in tons. This gives you a number of total balls and also some surface area in total. But after a while, your ball charge will wear down, and then you normally add up, as usually, the biggest ball size. But the complete composition is changing. And you see also on the number of the balls and on the total surface area, this is increasing, which is an indication that the complete charge is moving to finer ball sizes. And we do this again and again. And finally, the complete charge, the composition will get flatter and much more finer balls, scrap, scats, broken fragments, which you actually don't need in your mill, especially in this case in the primary mill. As I said, we came originally from dry grinding. In dry grinding, it's very common to dump the charge, normally every year of the mill, and then do some sorting of the sizes and also remove the scrap, the scats and so on. Of course, in this plants, mill downtime is not so critical like in mines where you have to run all the time. But we know from experience, with this procedure you get an average production increase of 3 to 5%. We have even some cases with more than 10%. I have also some example here. This was dry grinding of iron ore in Bahrain. Here we have been able to achieve an increase, a production increase of more than 15%. Honestly, of course, this was not only of the ball charge, we also installed some new liners, but we would say approximately 5% was due to the new liners, 10% was due to the optimization of the ball charge. So there you can see the high potential of optimizing only the ball charge. But coming now to mining, to wet grinding, sorting, scats removal is not really applied right now. According to maintenance staff, the effort is just too high in time, in work and so on. But as we know from customers, there are even some mines in Sweden, for example, who dump the charge when they do the relining, rubber lining or steel liner or whatever. And this would be the perfect possibility also to remove this scrap, this scat, which you don't need in your mill. And maybe some of you might know Mr. Malcolm Powell. He also did many years ago a test in a sag mill. He removed all the scats and he was able to get a production increase of more than 10%, which is not bad. But to be able to do this, you need the perfect tool, therefore. And here comes the actual innovation. The new CPB ball sorting machine, high efficiency ball sorting machine. This is pretty new. We just developed it the last year. We have now, since some weeks, it's protected by utility patent also. And this sorting machine is now 5 times faster than the conventional machines which are existing on the market. Maybe some of you might know these conventional machines with the 2 rollers. This is much too slow. And additional highlight, we now sorting out this unround and scats, these particles you don't need in your mill. And of course, due to the newest safety regulations, we have also some special key system to assure safe operation for operators, that all the safety covers are closed and so on. And there's not only the production increase, there are some other positive side effects you can gain with sorting. Maybe you know, or we know from experience, when you do relining inside the mill, you lose, due to the reduced mill volume, you lose approximately 6 to 7% mill capacity. But this would be the perfect possibility to compensate this. Of course, you will lose again this effect of ball sorting and scats removal, but for some time you can compensate the, let's say, the less mill volume you have due to relining. Another possibility, if you know how much scrap you're generating in your mill, you know also you can evaluate the quality of your ball, of your grinding balls. If scrap is increasing, then you know the quality is getting worse. Or you can also transfer the smaller balls you don't need in the primary mill to the secondary mills. Another possibility, you reduce clocking on grade discharge mills. And nevertheless, you have also the possibility to do recycling of the scats if you have separated it from the mill, from the normal charge. So maybe you ask yourself now, would it be economical for me if I would do ball sorting? There's an easy test you can make by yourself, and you even don't need the machine for this test. You just dump the charge. Maybe you are one of the minds who do this already. You fill in a complete new and balanced ball charge, and then you only have to monitor the effect on the capacity, respectively the fineness, how much you increase, how long is the durability. As I said, of course you will lose again the effect, but sometime you can compensate, you get some increase, so you can calculate finally by yourself if it's really economical for you. If you want some further discussion, of course you can visit me on our booth in the copper hall right there on booth number 253, or you can also send me an email. There is my contact. Otherwise, thank you very much. If you have any questions, I'm always also here for some minutes. Thank you.